Adding electrons to a Bohr Rutherford diagram can cause some people some grief, trying to decide the order that they should go in and remembering how many electrons can be in each of the electron orbitals. Let's go through an example. Consider the element calcium. Found here on the periodic table, we can learn a lot about what the Bohr Rutherford diagram will look like just based on its location. So to start off, we know that it is in the fourth period, so we know the first period will be completely full. That is, the first shell around the nucleus will have 2 electrons. We know that in the second period, all of those electrons will be present, so there will be 8 electrons in that orbital as well. If we go to the third period, we know that all 8 of those are present, and finally we find calcium in the fourth period, and it's in the second group, so there will be 2 electrons in that fourth orbital shell. Just a reminder about how to calculate the number of protons and neutrons, or not so much calculate protons, but determine the number. We know that the atomic number represents the number of protons. If we use the atomic weight, we know that it is an average of the mass of calcium atoms. We round to the nearest whole number to determine the number of neutrons for a Bohr Rutherford diagram. So we make the assumption here that the atomic weight of calcium is 40, and if we subtract that 20 that is mass of protons, we have 20 remaining, which is the mass and number of neutrons, and we put it there. So let's go ahead and start filling our electrons. In our first orbital, from the first period, we have 1 and 2. Though this is supposed to represent a 3-dimensional atom, we're in 2 dimensions and we try and put the electrons as far away from one another as possible. In our second orbital, we have 1, 2, 3, 4, and again trying to show them spaced evenly, but because we don't have that third dimension, the typical practice is to pair them up at this point. So we've now got 4 in that orbital, we need 4 more, so there is our 5th, 6th, 7th, and 8th. So we refer to that as 4 pairs, or a grand total of 8 electrons. In our third period, we see this repeated. We see that we have, again, 4 pairs equaling another 8, and ultimately our last 2 on the outer shell. And that is the Bohr Rutherford diagram for calcium with the atomic weight of 40.